Okay, for number 43, it says prove the volume of the cone with height h and base radius r is v equals 1/3 pi r squared h. I don't have enough room to do here, so I'm going to open up a notepad, and I'm going to do it on the notepad. And the first thing I would do is I'm going to draw a picture of how I would do it. I'm certainly going to do it by an integration. This is the xy axis. I'm going to put a line like this over here. And I'm going to say this is what my cone looks like, the understanding that the height of the cone is this over here. So this is the height, right? But when I say the cone is going to be being rotated about the y-axis. And this is the base over here. The base of it, they said has radius r. So that means if it's radius r, this distance here would be r. Right? That's radius of r. Right, so let me put the points down for you. The point over here is going to be r, comma 0, and this point over here is going to be 0, comma h. Again, when I rotate this thing around, it's going to form a cone. Right, so the way I'm going to do this over here is I'm going to do it by a method called shells. So I'm going to put the shell here. And I'm going to rotate that around, and it's going to create a shell. I'm going to add all the shells together. So I can put the integral down now, and I'm going to start my shell at 0, and I'm going to go up to r, and that's going to be 2 pi. That's the circumference of the shell, by the way. The shell goes around like this over here. So 2 pi, and now the question becomes, the radius of that thing is going to be some value x between 0 and r. So again, the shell, when you cut it out, it's going to look like this over here, where this is 2 pi x at this point. This will be dx. I'm going to put this over here. And now I want to get the height of it. All right? What's the height of it going to be? Well, something to do with that line there. So I need to write the equation of the line down for you. And the equation line is going to be y, let's see, minus, let's use this point over here. So y minus h equals, let's see, what's the slope of that line? Now, slope of that line is going to be minus h over r. That's the slope of that line. And then it's going to be times x. And it would be x minus 0, so I'm not going to put that down. So what's y going to be equal to? Y will be equal to h minus h over r x. Let's write that down. So it's going to be h minus h over r x. All right. I got my integral. I'm hoping my integral turns out to what they said it's going to turn out to be. And they said this is going to turn out to be 1/3 pi r squared h. Well, let's see if that's true. I'm going to multiply it out. That's 0 to r. That's going to be 2 pi h times x minus, let's see, 2 pi h over r x squared dx. Let's integrate, and you get what? 2 pi h x squared over 2 minus 2 pi h x cubed over 3r. Limits of integration go from 0 to r. Let's pop it in, see what happens. 2 pi h times r squared over 2 minus 2 pi h r cubed over 3r. That's the upper limit. Now the lower limit when you plug in x would just be 0. So I got some activity to do over here. I'm going to simplify. You get pi h r squared. That's done. What do you get over here? You get minus 2 pi h r squared over r. Not over r, I'm sorry, I'm daydreaming. Let me get my eraser out. I canceled an r, that's why I said r squared. It's over 3. I startled myself with the daydreaming. So what am I going to do over here? Common denominator is 3. And what do you get there? You get 3 pi h r squared minus 2 pi h r squared. What's that going to be? Let's see, 3 minus 2 is 1, so it's going to be pi h r squared over 3. Now, the way they wrote that down is they wrote down 1/3 pi r squared h. And it's certainly equivalent. Thank you.